2.5, derivatives of trigonometric functions. Well, we looked at the graph. We did this already, kind of did it early. So the derivative of sine is cosine, and the derivative of cosine, we said, is negative sine. Right, it's almost sine. Not quite, it's just upside down. So we're going to practice some problems using those two facts for a little bit, and then we're going to talk about the rest of the trig functions. So revisiting the differential rules. Find the derivatives of those two. So it says revisiting product rule and quotient rule. So the derivative dy dx on letter A is equal to first times the derivative of the second plus the second times the derivative of the first. And we took a gateway quiz in Honors Pre-Calc over the unit circle. We will take a gateway quiz in here over derivatives. And I will expect you to factor anything out that you can. So here we can factor out, oh, hello. Let's do that later. Let's factor out an x. And we factor stuff out because later, and we've already started this, we want to find zeros of derivatives. And so that's how you find zeros. You start factoring stuff out. But that's for later. Du dx is equal to bottom times the derivative of the top minus the top times the derivative of the bottom. All over the bottom squared. So that's the quotient rule. And we got a lot of cleaning up to do because we're not evaluating this. We're just finding the function, the derivative. So let's distribute negative sine through. Negative sine of x plus sine squared of x plus cosine squared x over 1 minus sine of x squared. Well, now sine squared plus cosine squared is 1. 1 minus sine of x over 1 minus sine of x squared. And finally, 1 over 1 minus sine of x. So we'll be looking for Pythagorean identities. That one right there. Speaking of that, let's talk about our Pythagorean identities. We have sine squared plus cosine squared is equal to 1. What do you get when you divide all that by sine squared? Can we maybe do the phone later? Okay, thank you. What happens when we divide by sine squared? We get 1 plus cosine over sine is cotangent squared. And 1 over, what am I dividing my sine? 1 over sine is cosecant squared x. So there's one that we'll have to look for. Now, not only do we have to look for that one, we'll have to look for how we can manipulate it. So if I had cosecant squared minus cotangent squared, I could change that to 1 because I minus that over. So if I see that, we can change that to 1 also. So you need to know how to manipulate them as well. Now if we divide all this by cosine squared, we get tangent squared plus 1 is equal to 1 over cosine squared is secant squared. So tangent squared, let's see, secant squared minus tangent squared, I could change that to 1 also. So you got to look for those things. A weight hanging from a spring is stretched 5 units beyond its resting position and released at time t equals 0 to bob up and down. Its position at any later time is this function, that's position. Now we're ignoring the fact that it's going to slow down. We assume that it just bobs up and down forever, which is not realistic, but you would get into that into later classes. what are its velocity, acceleration at time t, and describe its motion? So velocity is -5 sine t. Acceleration is -5 cosine t. Now to describe its motion, we do this a little differently than the book does. We say, where is the object stopped? And in this case, we're going up instead of right. And this one is down instead of left. So we want up and down. Now we do this on the velocity function. That's movement. Velocity is movement. Acceleration is change in movement. All right, so sine, and we're only doing this from 0 to 2 pi. We don't get every single value. Stopped, sine is 0 at 0 and pi. So we're going to put that on a number line. 0, pi is 0, and we'll make a note that we're ending this at 2 pi, which is also a 0, but we're not really including it. We don't usually include 0 and include 2 pi. It's the same spot. You just include one or the other. Now we need something between 0 and pi that would be nice. Pi over 2 would be nice. So the sine of pi over 2 is 1, but 1 times -5 is positive. Positive 1, but we just really care now that it's positive. Go ahead.
If we did end up writing 2 pi for the stop, would it be counted against us?
There's a chance it would. Yep. 3 pi over 2 is between pi and 2 pi. That'd be a nice one. Sine of 3 pi over 2 is -1 times negative is, oh, how come that was a positive? Did I mess that up? Oh, that should be a negative. Positive times a negative is a negative. I wrote that wrong. Oh, what? Oh, I cleared it. Undo. Thank goodness for the undo button. Oh, that's a little too big. I erased a lot of it. There we go. Nice tiny one. All right, so that's negative, not positive. Then sine of 3 pi over 2 is negative times a negative. This one's positive. So we're going to say up from 0 to pi. And one of the questions I had was, hey, wait a minute, I thought you said you're going to include 0. But 0 is a 0. There is no velocity at 0. So if it had velocity, if I could plug 0 into the velocity and get a value other than 0, then we're going to include it. But we can't here. All right, and then down is from pi to 2 pi. That's how we describe the motion in here. On an AP test, you'll never get the question, describe the motion. The questions you usually get is, when is the particle moving to the right? So that's why we focus on this rather than how the book answers it. Because you won't ever get this question. You'll get this piece, you'll get this piece, you'll get this piece. They'll never ask you this. That's too vague. All right, well, we've already answered that. We've already done these problems, just not with trig functions. A sudden change in acceleration is called a jerk. If you jerk someone, that's a sudden acceleration. So here's the way you think of it. If you have position and then you have change in position, that's velocity. Change in velocity is acceleration. A change in acceleration, they say, is jerk. Which you could say is I would argue, well, that's still just a lot of acceleration. But they're like, well, we have an equation for it, we can evaluate it, so we got to name it something, and we figure, well, if you jerk someone. Anyway, we don't talk much about that at all. Do we have some white space? Yeah, kind of above this. Above this chart, we got some white space. Right here, actually, right? Is that right? Yeah. I'll find some white space anywhere you want. We're going to take the derivative of tangent. But here's how I want you to do it. I want you to actually take the derivative of sine over cosine. And with your partner, you can discuss it. You can look over there. Do the quotient rule. Bottom times derivative of top, minus top times derivative of bottom. Clean everything up. And see what the derivative of tangent is. It always starts with bottom. Bottom times derivative of the top. So we have bottom times derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So all over cosine squared x. Well, that's going to be cosine squared plus sine squared over cosine squared. But that's 1 over cosine squared. 1 over cosine squared, and that is actually secant squared. So if you look at your chart here, it says that the derivative of tangent is secant squared, and that's how you can get that value, or that answer. Is just by doing the derivative quotient rule over on sine and cosine, you can get that. But you got to know all of them, all 6. The derivative of cotangent, we could do the exact same thing. That ends up being negative cosecant squared. Secant is secant tangent, and cosecant is negative cosecant cotangent. So let's do one more. I want you to do the derivative of secant, which we'll call 1 over cosine. So do the quotient rule on 1 over cosine and discover that it's secant tangent. Give that a try. I think it really helps in memorizing this to develop a couple of them, see where it comes from. I think it helps. I hope it helps. But remember, derivative of 1 is 0. Keep that in mind. So bottom times derivative of the top is 0. So bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. You all right? Equals 1 over cosine squared. No, excuse me. Sine over cosine squared. We have that positive sign over there. But that's sine over cosine times 1 over another cosine. We could split it up like that. Cosine, yeah. So that's tangent times secant. So they just say it's secant. We say it's secant tangent. So there it is. Now, so these derivatives aren't just coming out of thin air. We're not just pulling it out of the sky. We're developing it by using quotient rule or product rule or a combination, and that's what you get. Now, let's put in this so we have it all in one place if you want. Derivative of sine is cosine, and the derivative of cosine is negative sine. Now, I want you to take a look. The derivative of all the I call them the cofunctions. The derivative of cosine, cotangent, and cosecant all start with a negative. See how they're all negative, and all the other ones are positives? So all the cofunctions, the derivatives are negative. Don't try to remember that. Don't miss your negative signs. So, I mean, you can develop all 6 of these if you'd like, but at least we did a couple to help you memorize this a little bit. Find equations for the lines that are tangent and normal respectively to the graph of tangent of x over x at x equals 2. We only spend 1 day on this section, mainly because there's not a whole lot that's new. Other than memorizing what the derivatives are, we're going to do tangent lines, we're going to do stopped, right and left, that's old stuff. Just a lot of old stuff on a new derivatives. But I don't know what tangent of 2 is, so this is a calculator problem. So we have tangent of 2 divided by 2. Here's the function value. Now, how many of you are in physics? Several of you? The bad part is we do radians in here and they do degrees in physics. So you got to remember to switch your calculators because you'll get a lot of wrong answers if you don't. So you got to be in radians. If you're in physics, that's a little bit of a struggle throughout the year. So make sure you're in the right mode. So negative 1.092 or negative 1.093, either one. Now we need the derivative. And if we're going to practice the derivative, it's bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So there's the derivative. Derivative of tangent is secant squared. We developed that. Now we're going to evaluate this when x is equal to 2. I'll just do it on the calculator. 2 times 1 over cosine of 2, because I don't have a secant button, but I have a cosine button. There's secant, minus, I got a tangent button, that's good. That should be the top, and divide by 4. So, I don't think that was, is that right? Well, we're going to find out. Cosine squared. I was like, I don't think that's right. Second entry, second entry. I forgot the squared. Squared. Enter. Divided by 4. That's right. 3.433. But I mean, I wanted to talk about practicing, derivative, tangent, secant squared, but if I'm going to use my calculator, I can use math number 8. Math number 8 is derivative, there's x. Tangent of x divided by x. Evaluate at 2 should be the exact same answer. There we go. Ta-da! So if I'm going to use my calculator, I'm not going to take the derivative by hand. I'm going to let the calculator do the work, but I wanted to practice it a little bit. The answer for the tangent line is y plus 1.092 is equal to 3.433 x minus 2. The normal line has an opposite reciprocal slope, so y plus 1.092 is equal to negative. I'll take 1 divided by this number. So it's 0.291, but it's negative. 0.291 x minus 2. So opposite reciprocal. Find the second derivative of secant. The first derivative is secant tangent. You don't want to develop these every time. You got to do a little bit of memorization. You want to know that right away. And if you do your homework, maybe study it a little bit, you should pick it up pretty quick. And we're going to review tomorrow, and we're going to take the test on Friday, and then the other part on Monday. So it's a quick turnaround. You don't have time. You don't have a lot of time to memorize these. The second derivative, well, that's a product. So first times the derivative of the second. Derivative of tangent is secant squared. Plus the second times the derivative of the first, which is secant tangent. So there's a derivative right there, and then there's a derivative right there. Derivative of tangent is secant squared. Derivative of secant is secant tangent. But I can factor a secant out of this, and we get secant squared x plus tangent squared x. Oh, I have a possible Pythagorean identity. Secant squared plus tangent squared has a chance to be 1. But if we look back to one of them, or to where we wrote those down, wherever that is, all the way back. No? Yeah, here. Secant squared minus, if I minus tangent squared, that's 1. So we don't have a Pythagorean identity. If it was minus, we would have it, but it's not. So that's our answer. We cannot change that. We can't change it to -1 either, because if we ran a negative through, it'd be negative secant and negative tangent. They got to be opposites. They can't be the same sign. So you got to look for those Pythagorean identities if you want full credit. All right, so that's the notes. I forgot the instructions, so I typed them up there. Just find the derivative. Why don't you guys try 2 and 4, please? So first times derivative of second plus the second is secant. Derivative of x is 1, so plus the second times the derivative of the first. So we have a 1 here, times 1, times the derivative of the first. Then we can factor out a secant. All right, try 6. 6 has the product rule also, x times tangent. So you have to take first times derivative of second plus second times derivative of the first. So this one has a product rule in it as well. Little hint. dy dx, well, 3. First times the derivative of second plus the second times the derivative of the first would be 1. So there's nothing else we can do with it. 8 gets a little harder. Try 8. That is now the quotient rule. Quotient rule always starts with bottom. So bottom times derivative of the top minus the top times derivative of the bottom. Always start with the bottom on the quotient rule. You can talk to each other. You can look if you want. Ask me. Bottom, there's your top, minus top. Oh, I didn't take the derivative. Hey, back off. Just kidding. Minus sine, there we go. Minus sine of it. Oh, yeah. More than that. Jeez, what's wrong with me? Oh, minus sine of x. There we go. Let's do this. 1 plus cosine plus x sine plus cosine x squared. There we go. There's nothing we can do with that. 10. Let's try 10. I'll try to get it right this time. But stuff does cancel with 10. So 10's a little trickiest. All right, so 10. Hopefully you got a little head start here. See if I can actually do this. Is equal to bottom times the derivative of the top. I'm going to run out of room. Minus top times the derivative of the bottom over the bottom squared. This is going to be negative sine minus sine squared minus cosine squared over 1 plus sine of x squared. Everybody good up to that point? Well, now we can take a negative out of the top. Oops, plus cosine squared x over 1 plus sine of x squared. Well, that's going to be negative 1 plus sine of x over 1 plus sine of x squared, because sine squared plus cosine squared is 1. And our final answer, one of those cancels, negative 1 over 1 plus sine of x. That's the most, we can't do anything after that. That's done. I should warn you that, well, let me ask you. Do one of those signs cancel? No, they do not. I can cancel out all of this with all of one of those. I can do that and remove one of them. But you can't cancel parts of addition or subtraction. All right. This one is exactly the same. Actually, let's skip down to number 14. Let's skip down to 14. Letter A. Find the body's velocity, speed, and acceleration at time t. So velocity is velocity is 4 sine of t. Acceleration is 4 cosine of t. Oh, and I skipped over speed. Speed is the absolute value of 4 sine of t. It's the absolute value of velocity. So there's the speed. B, if I'm going to evaluate this at pi over 4, then velocity of pi over 4 is 4 sine of pi over 4, which is 4 square root of 2 over 2, which is 2 square root of 2. There's the velocity. The speed is the absolute value of that, 2 square root of 2, and I think we have labels, so meters per second. Meters per second. I tend not to put labels when we have an equation left. I don't usually put labels on those. But if we have a value left, then I start throwing labels on there. The acceleration, a of pi over 4, is, let's see, 4 cosine of pi over 4. That's going to be the same answer. So square root of 2 meters per except it's not quite, I mean, it's the same value. Whoops, did I lose the 2? Yeah. It's the same value, but it is a different label. It does mean something different. And we already described the motion with a cosine, so I'm going to skip that part. Go back and look at the example that we did. Questions on this part? What else we got that's maybe new? Oh, find the jerk at time t. So velocity is -2 sine. Acceleration would be -2 cosine. And so the jerk is 2 sine. Derivative of cosine is negative sine, but derivative of sine is just cosine, so the negative just follows along. The derivative of cosine is negative sine, so that's why the negative now is gone for that one. Try number 22. Find equations for the lines that are tangent and normal to the graph of y equals secant of x at x equals pi over 4. So you need a point and you need a slope. And the x-coordinate for the point is pi over 4. Let's see how far you can get on that one. You're going to have to remember your unit circle a little bit. So we have y of pi over 4 secant of pi over 4. Well, secant is the reciprocal of cosine. Cosine is square root of 2 over 2. So 2 over square root of 2. And you don't have to rationalize that. Equivalent forms are accepted, but we usually do on this one. So that's 2 over 2. That's just square root of 2. So square root of 2 is the function value. There's the point. Now I need the derivative. So y prime is equal to secant tangent and evaluate that when x is pi over 4. So secant of pi over 4, we already decided square root of 2, but the tangent of pi over 4 is 1. So this is also going to be square root of 2. Y minus square root of 2 is equal to square root of 2 times x minus pi over 4. There's the tangent line and the normal line. Y minus square root of 2 is negative 1 over square root of 2, x minus pi over 4. And we don't, you can rationalize that one if you want, but it's not really necessary. It's square root of 2 over 2. Equivalent forms are accepted. So you don't have to reduce like 2/4. You can write 2/4 on your paper, and you do not have to reduce it. Usually do. I mean, you don't have. I don't think that reducing 2/4 to 1/2 is taking a huge risk. You know, so you gotta calculate that on your own. What is a risk to reduce and what isn't? And if you think it's too risky to reduce it, leave it alone. Let's try this one. Letter A, it says, find the body's velocity, speed, acceleration, and jerk. So we have the position function, sine plus cosine. So velocity is cosine minus sine. Acceleration would be negative sine minus cosine. And jerk is negative cosine plus sine. So derivative of cosine is negative sine, so those will switch signs. Derivative of sine is cosine, those signs will stay the same when you take the derivative of sine. B, find the body's velocity, speed, acceleration at time pi over 4. So velocity of pi over 4 is square root of 2 over 2 minus square root of 2 over 2 is 0. 0 meters per second. Acceleration of pi over 4 is negative square root of 2 over 2 minus square root of 2 over 2. When we plug it into acceleration, well, there's 2 of those, but it's negative. Negative 2 of these. And so it ends up being negative square root of 2 meters per second. So there's the acceleration. And the jerk, I think, are going to be opposites again. So negative square root of 2 over 2 plus square root of 2 over 2, that's 0. Oops, meters per second. Oh, no, that's right. No, acceleration squared. And let's see. It's probably meters per second cubed. Letter C, describe the motion. We might need a calculator for this. We'll see. Stopped. We could probably do either right or left or up or down. How about right and left? You have the notes, right?
Yeah.
Oh. We do that on the velocity right there. So stopped, we have 0 is equal to cosine of t minus sine of t. So we need to know where sine is equal to cosine from 0 to 2 pi. What, pi over 4? Aren't they both square root of 2 over 2's? Where's the other one? Five pi over 4, that's right. So stopped is t equals pi over 4 and t equals 5 pi over 4. So that's where they're negative square root of 2 over 2. So we're going to throw that on a number line. We're going to start at 0. We have pi over 4 and 5 pi over 4. And we're stopping at 2 pi. Now here are the zeros. So this time 0 is not a 0. 0 actually has a value with this velocity function. So we got to find something in between 0 and pi over 4. I thought pi over 6 would be good. Now keep in mind that we don't have to actually find the actual value. We just need to decide if the value is going to be positive or negative. That's all we're looking for. So when we plug pi over 6 in, cosine of pi over 6 is square root of 3 over 2. Sine of pi over 6 is a half. So is square root of 3 bigger or smaller than 1? What do you guys think? Bigger than 1, right? So we're looking at a positive value. Square root of 3 minus 1 is going to be positive. So this is going to the right. Pi over 4 to 5 pi over 4, pi is in there. So cosine of pi is negative 1. Sine of pi is 0. So that's going to be negative. And then 3 pi over 2 is in there. And let's see. Cosine of 3 pi over 2 is 0 minus a negative 1. That's going to be positive. So to the right is 0 to pi over 4. 0 has value. Cosine of 0 is 1 minus 0 is 1. There's a value there. It's not a 0. And then 5 pi over 4 to 2 pi. If you include 0, we don't include 2 pi. It's the same spot. We usually don't include it twice. And then left is pi over 4 to 5 pi over 4. Questions on that? A lot of trig. A little review of our unit circle. Which of the following is an equation of the tangent line to that at x equals pi? So we need a point, and we need a slope. Give that one a try. Point and a slope. Oh, we're almost out of here. Y of pi. Sine of pi is 0. Cosine of pi is minus 1. I'm thinking it's negative 1. The derivative, y prime, is cosine of x minus sine of x. We're going to evaluate that when x is equal to pi. So cosine of pi minus sine of pi. Cosine of pi is negative 1 minus 0, so negative 1. The tangent is y plus 1 is equal to negative x minus pi. Well, I said there's no reason to change the form of it unless you're answering a multiple choice question and you got to get it to look like the multiple choice answer. This is going to be y is equal to negative x plus pi, so run the negative through, and then minus that 1 over. I think it's in letter A. Letter A is the answer on that one. I think we'll stop there.